everyone, welcome to Chemistry with Kat. Today I am doing an introduction on one of my favorite chemistry topics, acid-base reactions. Let's go. There are two theories behind acid-base chemistry. The first is the Bronsted-Lowry theory. This theory states that acids are the molecule that give up a proton or an H+ ion. A base is a substance that is accepting that proton. The second theory is the Lewis theory, and this has to do with electrons. The acid is the substance that is accepting an electron pair, and the base is giving up an electron pair. They really end up meaning the same thing, but you can decide which one is easiest to understand. We use them both interchangeably in chemistry, and neither one is wrong, so whichever one makes more sense to you, use. To be clear, the general guideline and what always helps me is that in a solution, the acid will raise the amount of H+ ions and a base will raise the amount of OH anions. The thing you have to know is your list of strong acids and strong bases. Most professors in universities expect you to memorize this list. The thing about strong acids and strong bases is that they will completely ionize in a solution, which means if you had a beaker of hydrochloric acid, for example, you wouldn't necessarily have the HCl molecule in the beaker. Instead, you'll have hydrogen cations and chlorine anions suspended in the solution. The one thing to note too is these hydrogen cations will bind to water molecules and create a molecule called H3O+. It's kind of the equivalent of a hydrogen atom, just when they're in water, we say it's H3O+. And here are some examples of acid-base reactions. We have hydrochloric acid, which is a strong acid, binding with potassium hydroxide, which is a strong base. This will create potassium chloride and H2O water. Next, we have sulfuric acid reacting with calcium hydroxide. These are again a strong acid and a strong base. This will create calcium sulfate and water. And remember, you always have to balance your equation. My last example is sulfuric acid reacting with sodium hydroxide this time to make sodium sulfate and water H2O. And again, remember to balance. If you notice, all three of these reactions have something in common. The products are all a salt and water. In tomorrow's video, I'm going to go over the classic university question of determining what salt will form from a strong acid and strong base reaction. If you enjoyed learning about acids and bases, please like this video and subscribe to my channel because almost the whole next week will be dedicated to acid-base chemistry. So tune in every day at 9 a.m. I'll see you here.